set it up so we just have a Echo over here and then one of your machines right here, and I'll just talk to the machines. Wouldn't that be better?
Great idea. Let's do it.
I mean, would that be more?
It might at some point get to an endless loop. So.
Which is fine, because that's what Disrupt is ultimately for me. It's an endless loop. I come here every year. I do exactly the same thing over and over again until I die, ultimately.
That's awesome.
So that was sad. OK. Talk to me about your approaches. You guys are coming from different worlds. You're a startup. You're well-established. Why don't you start from there? We'll go down and talk about the approaches to speech and speech integration and the products that you're working on.
OK. So wearing my AWS hat, so this is not about Alexa, even though, of course, we work with Alexa and components are in AWS. So one thing that AWS really emphasizes is to do things the way that our customers want to do them. And usually there are many different ways of getting to a solution, and not every customer needs every component of that solution, right? So, for instance, we have 4 or 5 different databases, and yes, if you want to run Oracle on AWS, you can do it. Okay. Now, the reason why we do this is because our customers are very diverse, both in terms of problems, skills, intents, and just personal preferences. Now, zooming into voice, actually voice isn't just a single thing. It's many, many components. So if you think about it, the first thing you want to be able to do is you want to have your system produce something that's human understandable. So in other words, text-to-speech in a natural way that can be customized and adjusted to humans, right? That's called Poly, and it has, I think, 15 different languages and, many, many different voices. And if I basically go to the AWS demo page, and you can hear all those voices. So, for instance, there's Australian English too, or English, or American English. But be that as it may, so besides being able to speak, you also need to be able to listen. So for that, there's something called transcribe, which will turn long-form conversations into text, and segment and diarize and partition them and so on. The next thing that you want to be able to do is you want to be able to have a conversation. So the first thing you need is a device with which you have a conversation. You can use anything else, but you can, for instance, use AWS Connect as a call center solution, so you can call a phone number. Then you need a system that takes care of the dialogue that happens. So we've dealt with sound in, sound out, and the number that you can call. All of those components can, of course, be used separately. This is exactly what Lex provides. And, well, as the name already suggests, it is, to some extent, the heart of Alexa. Well, different products have slightly different preferences and requirements, but you can then go and build with the dialog manager the entire interaction flow. You can have it fill slots. You can suggest what types of queries, responses, and interactions might fit in. And then, of course, in addition to that, you can fall back to humans. You can execute things, so you can make all of this serverless. You can interact with the databases, load from databases, dump into databases, just as you would. And in the end, if you want to do other finer analysis, then Comprehend will, for instance, tell you how a customer felt, what the sentiment was, basically just perform additional analysis. So even if you have a call center with humans, you can apply this. The key point is really you have all the components, you can take them all, you can take only a subset, you can take only one, and integrate them in whichever way works for you. And this way, you can get a very broad range of services. So that's the high-level view, and I should probably hand over to Jason too.
Sure.
Yeah, so our approach is based on the mission and the goal of encouraging these experiences to feel like a human in the room, right? Where you can interact with it, it understands you, and you can rely on it understanding you if you use messy, unconstrained speech, unconstrained language, right? So, where most technologies take the route of specifying what could be said to the system, we take an approach where we collect observations as to how people talk about a certain domain, and use that data itself to train the system. So there are no top-down specifications of grammars. There's no rules. There's no keywords, synonyms, dictionaries, anything specified other than the raw language used as the corpus to train the system end-to-end. It turns out most approaches out there will leverage something called parts of speech tagging and build trees out of the nouns, verbs, and adjectives that was said. However, if I said I'd give you $100, if you can tell me the last 10 verbs that I said, most folks won't be $100 richer, yet you understand everything that I'm saying right now, even though I'm speaking fast. The words are washing over you, and you understand me, right? And so we took that approach end-to-end in how we designed our technology stack. So you can say long, messy utterances. You can say something like, hey, man, I remember I was in California last year, and I dropped a bunch of cash on groceries. Could you just sum that up real quick and just give it to me, right? There's a lot of salient bits of information in that messy utterance, and our system would be able to extract all of the bits of information relevant to answer your question cleanly and crisply. So it's designed from scratch with this in mind. You can correct things. We have conversational healing. Along the conversation, you can diverge and say, oh, wait, let me go back to the last thing that I said and change something real quick. And at any point, you can have that flexibility and that freedom to go off script, correct things, and then come back and so forth. And so, it's built in-house from scratch based on research from the University of Michigan. In another life, I'm a professor of computer science and engineering. We've taken it to market and have massive amounts of success over the last 6 quarters.
How much of Alex's software are you using in your software?
Absolutely zero.
Oh, wow.
It turns out that...
customer.
Yeah, exactly. And, honestly, the way we've designed the stack is it's a platform that empowers you to build virtual assistants, right? So if you have an app, if you have a product, if you have a call center, if you have a device, and you want a conversational assistant, you use our platform to build that, much like a programming language to build a program. Yeah.
What's your view on the future of voice interaction? Is this a feature that's added on to modern products, or is this an entirely new track of interaction? Are we going to be talking to our computers most of the time, or are we going to be looking at interacting with our computers most of the time? If you wanted to start, Alex.
I think it's both. So there are certain established products where a voice interface will make them much more easily usable. I mean, cars, right now, you mostly press buttons, and I don't think it'll entirely go away because haptic feedback is really nice, like a steering wheel, as long as you need one. So you're probably not going to say, hey, turn left, turn right, so you're much faster. At the same time, if you need to go into some very detailed settings, a voice command is much easier. So this is one of those cases where the product will get better by adding voice. And then you have products which are essentially voice only. By now, there's an Echo with a display. It's called the Echo Show. But ultimately, it's a voice product. You talk to the device, it talks back at you. And as time progresses, it gets smarter, and it learns based on you and interactions with everybody else how to make it better. Now, if you want to build your own Alexa-like product, you can go to AWS and use Lex and other tools to build these. And we've given you all the components. So for instance, if you want to build a dialogue, well, you can essentially model the various parts that you require, give a couple of examples of what you expect as an answer, and then we use appropriate deep learning to match this also against more free-form conversations, right? So I don't know whether whether we are necessarily able to catch slang quite as in the way what we just heard, but okay, I think I would have trouble sometimes understanding that, but I'm not a native speaker. But that said, it's each individual component. And so, for instance, if you have a very simple device where you just press a button and it says, well, the garage door is open or the garage door is closed, then the only thing you'll really need is text-to-speech, right? So it's not clear that you always need the full dialogue agent. You need voice as an augmenting device. And this is really what we're here for.
Yeah, no, so voice and conversational experiences is a means to an end, right? And not an end in and of itself. What we aim to do with technology, period, just the overarching thing about technology is we want to reduce complexity in our lives and improve our quality of life. That's it. That's the motivating function for evolution and revolutions with technology. And insofar as speaking and interacting with language, which we learn to do from the age of, I don't even know, 1, if we can just use what's natural and innate in all of us to make our lives easier, to do something complex. Oh, I want to take a long road trip to, New York. What do you think? Am I going to be able to get there with 2 tanks of gas? And then that interaction, being able to get the insight of, well, actually, you're going to have to stop at 4 gas stations for this trip. And optimally, given how you've driven for the last year, you should stop at this location, this location, this location, and this location on the way for a most efficient trip. That's what we want. That's improved quality of life. That's reduced complexity. And so when we're doing it right, that is the outcome. When we apply conversational AI, voice AI, to a problem, the outcome of doing it right is this is better, right? So I do think it's coming, and as we develop, it'll become more prevalent because it's natural and innate.
Are you guys in charge of that interaction, or are you just in charge of the voice going back and forth? I guess you could start, Jason, because I mean that interaction you just described, and there was a demo online of what you're working on, and everybody's probably seen AWS services. Is the expectation that eventually one of the big players is going to connect to your platforms and say, okay, this is the data that we have accessible to that user, and let's spit it out when they ask for it, right? Or are you guys in charge of that?
So the way that this has to look is as a toolkit for development, right? Because when you look at code bases and tech and integrations, it's code, it's APIs. The data is behind some kind of API or query language, SQL or Cypher query or query language, et cetera. So the conversational AI piece is another kind of toolkit for development, right? So you'll build the AI to understand how humans speak, and then that AI will have the tooling so that you can integrate it into code, right? And so developers and designers will have at their disposal, SDKs and so forth for the code pieces, and then they'll have a platform or a toolkit for building the brain that they then hook in. And so we have a brain. Clink has a brain. It's an extremely powerful brain that's built from scratch and looks different than anything else in the market. And we believe that brain represents how this should work in the future. And then you have other services out there with other approaches and other brains. And so I think that's how it fits into our ecosystem. Yeah.
Alex?
OK, so so it's quite reasonable to assume that some customers may not be NLP or conversational AI experts. Right? Actually, a lot of customers probably aren't. And for them, probably templates may be the right way to go, to have a couple of reference solutions and tell them, look, start from there, modify it in maybe a minor way, and you get something. And we have some blueprints, for instance, right now for simple examples, how to do this. At the same time, you want to not constrain the developer and want to allow them to add and to modify and to extend the system as far as they're able to, right? And I mean, this goes as far as us, for instance, making available in source code for deep learning a full NLP suite of tools on the Gluon NLP toolkit. And you can basically take any of the latest papers, and we have an implementation that's tuned efficiently. And you can just open source, git clone it, and build your own system entirely from scratch there. So that's how far we go if you want to do it by yourself. Now, most customers sit somewhere in between, and they may have some very specific expertise, and this is where they may actually innovate. And then for the rest, we take care of it. Now, one thing that's quite often confused, and this is just because humans work this way, is just because something sounds natural, both in terms of voice maybe or in terms of language, doesn't actually mean it's intelligent. Probably the best example would be Eliza. I don't know who's, okay, this is probably half the audience is too young to remember this, but this was one of the first text-based communication systems, and it would basically just turn whatever you say back to you as a query. And it was meant as a therapeutic tool for psychoanalysis, mind you. And the first time you use it, and if you don't know what's going on, for the first first minute or two, maybe for 5 minutes in some cases, you don't notice that you're actually talking to a machine. So the bar for building something that seems intelligent isn't that high, at least if you want to fool people for a short term. For something that's more persistent, there's quite a gap between the pieces that you need for the actual, chatty conversation and the intelligence that goes on behind the scenes. You want to be able to query a knowledge base. You want to integrate it with a lot of other systems, which can, for instance, ingest data. And this is the full system where, essentially, we are helping developers to build things. And so basically stay tuned until reInvent, and you might see some nice things. And that's all I can say.
I want to go back to the sci-fi stuff near the end, because this is cool. One of the most interesting things I've learned about natural language processing is the use of the Enron corpus. I don't know if you heard about this thing. It was basically just a massive data dump from Enron, because it was the only example of text that they had, human text that people were talking, but it was all a bunch of dudes just talking about their boats and Dallas and where they're going to go, which strip club they're going to go to at night. So that's the Enron corpus. So it actually created a prejudice within a lot of natural language programming systems. How do you guys avoid that? How do you avoid the tendency as a non-native speaker or as for the machine to not be able to hear you, I guess? And how do you fix those things that are actually going to be issues over the next couple of years?
Yeah, I mean, that's a really important point. It turns out that these models are completely subject to the data that you expose them to, right? So everyone knows about Microsoft's Tay debacle, right? The Tay went out on Twitter. There's some bad data on Twitter, so this is a bot that would start tweeting and learn from what it was seeing on Twitter, and it learned all of the most offensive.
It was the worst stuff possible.
Yeah, the worst stuff possible, the worst of humanity, racist, sexist, all that stuff. And so you have to be very careful. There's going to be known bad data that trains these models to not be great. And then you'll also have unknown biases in the data sets you have. And depending on how you're applying the AI and how that could manifest itself, that needs to be something that designers and folks wielding this technology needs to be conscientious about and cautious. I mean, it was very expensive for Microsoft, that mistake. And we need to watch out to not make those.
Alex?
So I think this is really the point where a lot of the hidden cost in building such systems comes in, that you really want to do good quality control. So for instance, if you have a picture of monkeys and they get misrecognized as humans or vice versa, then this is a no-no, and it's especially a no-no in this country, right? And, for a machine learner in general, okay, fine, I miscategorized category A for B, no big deal. That specific error is really embarrassing, and you really need to take great care to avoid that specific one. So this is where a lot of the testing, making sure that the distribution of what you're getting from your customers matches what you train on. And to some extent, you're only going to see that once you start deploying a system. Well, for instance, if you have a product that wants to look at what is not safe for work, you'd say, hey, look, that's an easy thing, right? I mean, as long as people are closed, it's fine. Well, actually not quite, because what goes in the New York Times and what goes in a tabloid may be very different. And what is offensive here and what is considered offensive, for instance, in the Arab world may be very different still. So that is something where only by working with your customers, by getting their feedback, you can really ensure that you're going to take care of the, well, unintended biases, that you iterate very quickly, that you allow customers to define some of their data sets, to define some of the specific terminology, conversation flows, and so on, and to make sure the entire system remains debuggable. And to some extent, that's a little bit the tension that we're seeing right now with a lot of fully integrated deep learning models, which can make it non-trivial to debug them, right? And we've had fun with that ourselves. For instance, you might use a machine translation system, and then you run some experiment, and all of a sudden it produces a translation that you didn't expect, and then you need to work back, and the more end-to-end trainable it is, the harder it becomes to analyze. So this is essentially where all the engineering comes in, because otherwise I can git clone the models like in the Gluon NLP toolkit and just use them. But then you need to know what you're doing. So that's why I think it's an exciting time.
In terms of privacy, would you ever want, is it tempting to leave the microphone on all the time so you get as much data as possible? And how would you react to that? How would you do that?
Yeah, well, data is gold in this AI revolution, right? Data enables us to make these models really useful. So we do have a very delicate balance to make between having copious amounts of data to build good stuff and making sure that we're conscientious about how that data might be misused or what hands it might fall into. Now, from my perspective, I want to get as much data as possible. I mean, come on, look, Google has Gmail. They love getting all that data. Everybody, the whole planet's emails, come on, right? And you have to be very cautious and self-regulate how you manage that data, and when you make a big boo-boo, like Facebook, but when you make a big boo-boo, the society comes down on you like a sack of bricks, right? But, I think what we're going to see, and I'll just say what is actually going to happen and is happening, is we're erring on the side of development and tech. We're erring on the side of collecting the data and then trying to be responsible, because that's what's allowing us to create the kinds of technologies that are improving our lives. And so I'm a big proponent of, collect the data, do good stuff with it, and self-regulate as we go forward, right?
Okay, so this is actually the wonderful tension between doing a startup and, working in a slightly larger place. So the thing is, you absolutely do not want to violate the trust that your customers place in you, right? And so you want to be super careful that you never do anything that you didn't tell your customers, that you treat the data of the customer with respect, that you make sure that there's no data leakage, that you make absolutely no mistakes. Because with a startup, let's face it, okay, fine. I mean, you fail, you go to an angel investor, you do another version, and you're back in business. So maybe you just rename the thing, right? We can't rename, right? So this is one of the things where, well, to some extent, you're going to get a much more conservative and, with that, maybe also somewhat more expensive approach from a place like AWS, because we really value the privacy of the data that our customers have, right? So, that's why you have HIPAA compliance, that's why you have all the other security, encryption, and protection guidelines, which make sure that the data that the customer entrusts us with is really safe and secure and not abused in any way. And so, whereas otherwise, I can go and scrape data and, copyright be damned, I trained the model and nobody's going to come after me if I'm a startup, right? And I've been there as well, so this is...
Okay. Yeah. I think their statute of limitations is probably over by then, so there you go.
Yeah, no, so first of all, I wasn't advocating, taking people's data and doing nefarious things with it. But the thing is, there's some industries that are regulated. So you mentioned HIPAA compliance. The healthcare is regulated. Your privacy is regulated legally. In financial services, there's laws as to how data can and can't be used and how data can and can't be transferred. However, when it comes to other kinds of data, your personal data, it's not regulated. You have a terms of service. You have a contract that you sign, a EULA, right, that you click. I want to log in and I approve this message. I read the thing which no one reads. That's how it's regulated. No one reads that. We just have an innate trust, right? And when it's violated, Facebook isn't criminally being prosecuted for breaking a law, right? Now, he did have to speak to Congress, but in this unregulated world, there are norms and ethics that are emerging, social mores that are being defined now as to things that are just not good to do with data. And we're behind the curve as to what are the established legal specifications as how they could be used. Now, I don't know, man. I don't know where you guys sit on this, but you can imagine some folks would want more government telling us like how our data should be used, and then you have libertarians that will be like, I'll sign the contract, contractarianism, et cetera. So I think that we have to understand that landscape and be conscientious of that landscape as we move forward, right? Yeah.
Okay, our sci-fi question. We only got about 2.5 minutes left. At what point, what year, are we literally going to be able to set up 3 machines to talk to each other in the way that we just talk to each other? as speech guys, right? So let's think about that. When will we be able to Eliza this thing out to a degree that it sounds human?
That's I love that question. Like, that's a very interesting question, and I think it's coming. I think that eventually we're going to get to the place. We see it in sci-fi movies now, but we haven't realized it really in industry or technology. We'll come to a place where we start building these assistants for recreation. We'll build companions to literally be our friends. And those companions will have personalities, et cetera. That's going to happen, right? That's just the human psychology, right? We're going to want to recreationally have a buddy when it's good enough to be interesting. When we have that, then we're going to have a little bit of diversity in these personalities, and then we'll be able to set them up to talk to each other. That's my thought.
Okay.
What do you think?
Alex?
Okay, so there's one part where I think it's a terrible idea to have this happen.
Well, then I could just go eat lunch. Or
so basically, if you want to actually negotiate, discuss, achieve some outcome, language is a horribly imprecise way of defining this. I mean, mind you, this is why people are putting contracts on Ethereum, right? Such that there's a computer program that is executed and it's irrevocable and so on. And you want to have, for instance, theorem provers that prove that your voting machine is correct if the law is written in ambiguous ways, all those things. Or where people said, well, no, that's actually not what I meant, even though they tweeted about it the previous day, right? So this is why language as a means for communication between machines is making things a lot less precise than what they can be. And I don't think it should be a goal unto itself to accomplish this. Might I have such interactions in the context of, well, entertainment? Yes. Might I have it in the context of where no other way of communication between those devices might exist? Yes. But short of that, I think we have a lot of other challenges to overcome before we even get to that. So being able to talk to this device like to a companion, I think this is a great thing that we'll see eventually in the future, especially with people getting older, being lonely. It's a lot better to talk to Alexa rather than not have the nurse show up in the old age care home when you push the button and, well. So there are plenty of opportunities, and I hope they'll make our life better.
Wonderful. Well, thank you guys. This is fascinating, fascinating stuff. Thank you.
Cool. Thanks.